Yes. Okay. So as part of our last class, we discussed database connection, right? How to connect to database and how to get the records.
Right.
So did you install MySQL database?
Actually, I did not.
Okay, fine, no problem. So whenever you are trying, no, maybe you can share the screen. So how to install it, I can able to help you out on that. Then you can able to practice this JDBC connection, correct?
Sure,
Yeah.
definitely.
Yeah, fine, fine. Okay, now today what we will do, we will start a different topic, threads. Okay.
Okay.
Okay, let me, yes. We are going to start with threads, right? So first we will see theoretically why we need threads and where we are using threads exactly, some real-time examples of threads, okay?
Mm-hmm.
First, right, say for instance, if you see our operating system, meaning our machines, laptops, so we are doing so many things, correct? See, in our case, I opened Eclipse and I'm also using Zoom, right?
Right.
So there is two things are happening parallelly, correct?
Mm-hmm.
So Zoom is recording the video and Eclipse also is working, and there are so many things are happening behind the screen, correct? If you want to see all those things, set show taskbar. Did you see this?
Right.
There are so many things are happening. So far, I told you only two things, correct? Zoom
Mm-hmm.
and Eclipse. See here, Zoom, and see everything is a one task. See here, but we don't know all those things. But everything, there are so many things are happening parallelly, correct?
Right.
So Eclipse is there, and Chrome also is running. See, Chrome is running. So what are we knows? So the rest of things are related to operating system tasks, correct? So
Mm-hmm.
instead of so here multiple things are running parallelly, correct? It is not a sequential programming. It is a parallel programming. Okay, it is a parallel programming. So if you don't have this parallel programming concept, so we can able to use only one application, meaning we can able to open only Eclipse or only Zoom or only Chrome, correct? So this is a sequential programming, correct?
Right.
So but we are not using sequential programming. We are not using sequential programming. We are using parallel programming. So we are using parallel programming. That's what we are doing. Multiple tasks, correct?
Mm-hmm.
So each task, how we are handling. Say for instance, if you take this Eclipse, this one example is Eclipse only. Eclipse only, right? So when you are opening this one, and what we are doing here, just open this one. So I opened it, correct? So now what I'm going to do here, I'm going to type something here, presently. So immediately what is happening here, did you see this? There is some error came, correct? So if I did save, let me fix it immediately. So when I did save it, immediately it will recompile it. It will create the dark class file and it will paste into bin folder, correct? So there is another thread is also working on this, correct?
Right.
Entire this thing is a one task. Eclipse is a one task. Under that there may be multiple subtasks also running, correct?
Right.
Okay. Eclipse is one task and Chrome is another task. Okay. And say for instance you open another task is Word document. So these are different tasks. It's parallel, it's running, correct?
Right.
So now if I open, let me open the Word document. One more task I'm going to open it. So did you see this? Whenever I'm typing here, it is checking immediately the
That's
spelling mistakes, correct?
Mhm.
Immediately it is checking spelling mistakes and grammar mistakes. So these are separate threads, correct? Entire thing is a one task, correct?
Mm-hmm.
Under that we have a sub task, sub threads are running for each task, correct? So that's what you are seeing. So each thread so these subtasks are handled by multiple threads, correct? This spell check is a one particular thread, and you sometime will see here green underscore, correct? It's a grammar mistake. So that is also sub thread, meaning, so whenever you are running subtask, each subtask is having multiple threads, parallel threads are running inside that. So this is the thread, this is the thread, this is the thread. So that's what I mean, you can able to see all the changes, meaning the spell check, grammar check immediately, right? Someone need to work on that, otherwise we are not able to see the change, correct?
Mm-hmm.
Otherwise, what do you have to do? We have to first write I mean all the things, then select everything, then you have to click a button like to see the spell check. We have to click a button to see the spell check, or we have to click a button explicitly to see the grammar mistakes. But we are not doing that one, right? Immediately we are getting the change, correct?
Right.
So because we have a separate threads are running behind the screen, separate threads are running behind the screen. So that's what we are seeing the changes. So these are separate tasks. It's running parallelly, and inside each task there is multiple threads are running. So that's what we are seeing all the results in a sequentially, sorry, parallelly.
Right.
These are the some of the real-time usage of threads, correct? Just we saw these examples in our operating system itself. So how the parallel program is running, correct? Now the
Right.
second question is, but how many processors we have in our CPU? Only one processor, right?
Mm-hmm.
We have only one processor, but correct, we have only one processor. So whatever program it is running, whether you are using Word or Eclipse or Zoom, so all these programs need to get some particular time from the processor, correct? We have only one processor, correct?
Right.
So we have only one processor, and we have only one RAM, which is having some 3 GB or 4 GB space, correct?
Mm-hmm.
So what this processor will do, so each task whatever you are running here, this is subtask, right? So each task having multiple subthreads, correct?
Right.
So each task is having multiple subthreads. So each thread, meaning thread, we will see all those things later. So these threads will take a nanosecond of time from the processor to execute and to get the results, meaning execute, meaning, so what it will take this entire code and it will go to the processor, and it will execute it and will try to get the results, whether this word is having any spell check or not. So that is one separate thread is there. So it will take some time from the processor, and it will check this one, does this word is having any spell check? If it is there, it will make an underline with red color, correct? It
Mm-hmm.
will take nanoseconds. Why? Because there is so many threads are running, right? So every thread will take some nanoseconds of time, it will execute it, and it will publish the results and the corresponding window.
Right.
So this each thread cannot take hour of time. If you take hour of time, rest of the programs will not execute, correct?
Right.
So just only nanoseconds, that difference we can't see it, nanoseconds of time. So that difference we will not see even if you type the word, right? So whenever I'm typing, so immediately it will not get, it will take some time, correct?
Mm-hmm.
It will take some fraction of seconds. Did you see this? So that second difference we will not able to see, because it will go to the processor, it will compile it, and it will get the results back. So that time you will see the delay. So that is a sub threads in a task. So each thread is having sub threads. So that we will see what is subthread and how the parallel program is running, all those things. These are the some examples of how in real time we are using threads indirectly, even though we don't know, but we are using it.
Right.
That's what, right? If sometime what you will do, if your machine is hang, what you will do? You will do right click, you will go to here, set priority. We will see all those things. What is priority? All those things. Okay. End process. I told you, right? There is so many processes are running, correct? So if you
Right.
want to kill the process, what you will do? You will right click and end process, correct? Zoom will, you're killing one process. There is so many processes are running. If you want, you can able to kill one process. Did you see this?
Right.
So this is, there is so many processes are running. So in that one process, you can able to select it, and if you want to increase the priority, all those things we will see it later. So many processes are running, and under each process there may be n number of threads are running. So one process is Eclipse, and another process is this Word and Google Chrome. These are the different processes, and each process is having multiple sub threads. Correct?
Mm-hmm.
So these are the some of the examples of parallel programming. The sequential programming meaning one by one. If you don't have this parallel programming concept, then what we can do, we have to open only Word or only Chrome or only Eclipse. We are not able to open all programs together. So that is a sequential programming.
Hmm.
So you got some rough idea, right?
Yeah.
Okay, now let me show you one simple thread so that you will get a more idea. Okay, let me write, create a new Java project. Okay, so now what I want to do, now first what I will do, I want to write one for loop here. For int I equal to 0, I less than 1000, I plus plus. After that, what I want to do, I want to print the values. Correct?
Right.
I. So what it will do, first it will execute this for loop. Correct?
Mm-hmm.
After that, what I want to do, I want to print one more for loop values 101 to 200. Did you see this? First it will execute this for loop, then only it will execute it, right or wrong?
Right.
If you see these results, you will see it. Did you see the sequence? What is the last number? 199. What is the first one? 0, correct? And you will see the numbers in a sequence, correct?
Right.
So 99, and it is started with 101, 102, something like that.
Okay.
So if you keep equal here, you will see these numbers also. Now you will see everything 1 to 200. See, the last number is 200, and you will see here 100 also, correct? You will see the numbers are in sequence, correct?
Right.
Say for instance, the first for loop is taking 10 seconds. Just assume it is not taking that much time, just I'm telling. And second for loop is taking 10 seconds. So to see the entire results, we have to wait 20 seconds, correct?
Right.
So this is taking 10 seconds and this is taking
20 seconds.
10 seconds. Total 10 seconds time we have to wait, correct?
Oh.
So this is an example of parallel programming, correct? So these two are not running in parallel. So these two are running in sequential, correct?
Right.
So now I don't want to run so this in a sequential order. I want to execute these two in a parallel, meaning side by side, meaning it should these two for loops run in a parallelly,
Okay.
so that I can save 10 seconds of time, correct?
Right.
So now it is taking 20 seconds of time, but I'm going to do the same task in 10 seconds so that I can save 10 seconds of time, correct?
Mm-hmm.
So how we are going to do this thing? So this is a sequential programming. So let me change this one. So this is an example of sequential programming. So now let me write the same thing. I'm going to modify by using parallel programming concept. So how I'm going to finish this task in 10 seconds. Let me write. Now basically I want to do two tasks, right? One task is I want to print the numbers from 1 to 100, and second task is I want to print the numbers from 101 to 200. Basically two tasks, correct? So I want to start the two tasks parallelly. It should finish in 10 tasks, correct?
Mm-hmm.
So now first what I had to do, I had to create task 1. After that I had to create task 2, correct? I have to start these two tasks together, correct?
Right.
So then parallelly it will start executing the for loop, correct?
Right.
So how to create these tasks parallelly, how to create two tasks separately, and how to start these tasks, correct? We have to click some button or somewhere, right, to trigger to the task initiation, correct? So that we will see. So for that what we have to use, we are going to use threading programming. So how to create a thread, meaning we are going to create two separate tasks. In this case this entire thing is only one task, correct? In one task we are trying to do this thing, so that's what it is, doing the things in a sequential, correct? Now we are not going to do entire thing in one task. We are going to split the task into multiple subtasks. Okay, if you see in our operating system also, let's go back one more step. If you see here, there is a right click here, see here, end process is there, end process tree is there, meaning so this is a parent task and this is a subtask. Under Zoom there may be n number of subprocesses also running. That's what they're telling, end process and end process tree.
Hmm.
Did you see this?
Right.
For everything you will get same thing, end process tree. End process is a parent task. Under that we have multiple subtasks,
Okay.
so they are running parallelly. The similar way, so this is a parent programming, this is a parent programming, and under that we are going to create subtasks.
Hmm.
Clear, right? This example. So how it's how operating system is working, correct?
Right.
So in case of in the previous example, so only one task is there, there is no subtasks, correct? And
Mm-hmm.
only one task we are doing one by one.
Right.
So here we are not doing like that. We are going to define two subtasks and we are going to perform the operations.
Running it together.
Yes, correct. So now I'm going to create a task 1. So for that, I'm going to use some class called task 1. Okay, this class is not a ordinary class, so I'm going to make this class as a okay. Now let me write it. Okay, public void run. So what I want to do? Ultimately, I want to display the numbers, right? Correct. So let me copy the task number 1 operation. What I want to do exactly. So this is the task number 1. Correct. Now let me copy the same one more task. So this is task number 2, correct? And now what is the task number 2 will do? It should print numbers from 101 to 200, correct?
Right.
So this is the first task and second task. To call this task, I have to create an object, right? Correct?
Right.
So to start this, I mean to execute this method or operation, I have to create an object and I have to call the run method, correct?
Right.
T1 equal to, so far it's clear, right? This is just object oriented programming. Just we are doing how to start the task. T1 dot run, correct?
So this time, okay, yeah, okay.
So this is normal programming only. Just so far we have not entered into the threads. Just I created 2 sub tasks. This is like a second task. I'm going to start it. Yes.
But
So
it's the same
2.
concept. Okay.
This is also kind of sequential programming, correct?
Hmm.
If you see, then it will give the results in the same order. It will take 20 seconds only. Why? Because you are creating 2 objects. First it will execute this task, then only it will come to
That has.
yes. If you see the stack method stack, maybe we discussed strong language first, right? What it will do? It will load main method. After that it will load object 1, task 1 run method. Then it will load run 2 method. Then it will start executing. Finish run 2, then run 1 and main method. This is a kind of sequential programming, correct?
Mm-hmm.
It is a method stack, it will be executed in this order, correct?
Right.
But it is a sequence. First main method, it will start executing, then after that it will start executing task 1 run method, task 2 run method, correct? Then it will start removing from this, it will remove it, and after that, and finally main method will complete 100%. And but it is a sequential programming. I don't want to follow this way, correct? So this is also indirectly a sequential programming. It will take 20 seconds only, correct?
Mm-hmm.
So how you know whether it is taking 20 seconds and all, right? So I want to print the number and I want to wait for 1 second. So if you see that one delay, if you want to give the delay, right? So there is a method, there is a class called thread dot sleep. So just give here 100 seconds. Sorry, 100 milliseconds. Sorry.
So it's not gonna wait for 100. It's not 1 second either.
It's not a 1 second. If you want to give 1 second, we have to give 1000 milliseconds. Okay, thread dot sleep, what it will do, know? So wherever you are running, it will print the number and it will wait for 1 second.
Okay.
So
Right.
this is whatever you are passing here, it's a milliseconds. So thread is an inbuilt class, it is available under java.lang class. Sorry, it is a class, it is available in java.lang package. And under that there is a method called sleep. If you pass something here, it will execute it and it will wait here for 1 second. After 1 second, again it will go back for next iteration.
Hmm.
Manohar, I have one question.
Yeah,
Actually.
yeah.
Yeah, actually, thread.sleep. So
Hmm.
there is so many methods. So I can use anyone whenever. How can I know that? Suppose if you got thread dot and there is so many methods showing, no?
Yes. That we have to read the document basically. Which method we have to. What is the purpose of each method?
There is some document, no?
Yes. I used to give the link, right? That Oracle link. Did you have that link?
I think I forgot. Sorry.
No problem. I'll give back again. So if you don't know what method to use, how many methods are available, so there is a Oracle website. If you go there, right, so they will explain each class and each method. Second, I'll give. Even if it is not there here, right, I think you can able to find. So wherever you installing your JDK, right, so
Yeah.
there also somewhere you will get, say for instance, where you installed installation, go here, then where is your JDK? Did you see anywhere Java?
No.
No, it's not there, right? You can see in JDK program files. Yeah, also it is not there. There is one folder you will see doc. Where is
No.
the doc? Yeah, there you will get this documentation. Really, source. Okay, that's fine. Maybe I forgot that link. I will give you the link.
Okay, thank you.
So if you use that link, then you can able to navigate all the classes with all the methods. Now I said one class thread, right? So inside the thread there may be n number of methods. So you can able to see each method what it will do, and it will give some example also, so that you can able to understand very easily. So what the method will do exactly, correct?
Okay.
So now thread. is a class and sleep is a method, and sleep it is throwing an exception of compile time. So we have to write a try catch, or else we have to throw the exception. So now I'm going to write try catch. So now I have written try catch. The same delay, 1 second, I want to see here also. So 1 second means it will take more time. Let me make it 100 milliseconds. So now I'm printing one number and I'm waiting for. So now let me run it. We will see the delay. Did you see this? You see some delay, right?
Yeah.
So it's executing sequentially. So 100, and now it is started second for loop, correct? It is sequential programming, right? So totally it will take. Yes, now it is finished. Now I don't want to do these things like this. I want to start these two tasks parallelly. So how I'm going to do? So for that we have to extend this class thread. Okay, we have to extend this class thread. Okay, and extend this one also with threads. Thread. Okay, now thread is a class. Under thread, so there is a method called run. If you expand here, you will see run. Did you see this? Under thread, there is a method run is available, correct?
Right.
The same method I am going to override here. So run is not my method, it's a overridden method. So meaning if you want to know whether it's overridden method or not, you can add here, correct? So now we are not using JDK 1.5. We are using 1.4. Okay, let me change because this is annotation, right? So annotations are available only in JDK 1.5 onwards, correct? So now let me change the JDK 1.4 to 1.5. So Java compiler. Yes. If you see here, it is pointing to 1.4. Okay, let me change to 1.5. Now annotations will work. See, now you will not see any error here, right? So meaning it's an overridden method. It's not my inbuilt method. So that I can confirm, correct? So here also you can check. If you want to check any method, it's overridden method or your own method, just add this annotation. If it is not giving any error, meaning it is there in superclass also, correct? So there is a method called run. So I'm overridden that method, correct?
Right.
So now I am going to start this thread. Now tasks are ready. How to start that thread? So we have to call start method. We will see what is start method later. So here also I am going to call start. So now, yeah.
That's a quick question. What about the method that I had read public void run? So instead of run, if I'm not taking the
Yeah, I will tell you, yes. Instead of start, you can call directly run. That's what you're asking, right?
no, instead of run, I know that's one of the object from thread, right? So I can put it as something else I wanted to put. So is that gonna work?
Yes, you can write anything under this run method. Whatever operation you want to do, you can write. To do.
Instead of run, I could say something else, a. So that's what I'm saying is. So is this gonna?
So instead of run, you want to write your own method here?
Yeah.
No. There is a relation between start and run.
Okay. Oh, okay.
Did you see here? Are you calling here run method? You are not calling run method, right?
No, I'm not calling run.
You are calling start method. The start method will call indirectly run method.
Okay. So there is a connection.
Yes. How the connection, and I will see it later. Okay. For time being, you can just assume inside the start method we are calling run method. Okay. So that's what we should not call directly run method. So I will tell you after some time. Okay. Okay. Now let me start the main programming. And did you see this? How the numbers are displaying?
Together.
Together, correct? Meaning parallelly these two threads are running. So that's what you are seeing, two numbers sequentially.
Okay,
Sorry,
so
parallelly.
95. Okay.
You understood, right? Now the difference.
Right.
So two numbers are printing, meaning two threads are parallelly running. So it's giving two outputs. So if you want to calculate total how much time it was taken. So okay, here new date get time. So it will give some milliseconds of time. So now it is once before starting the task, and once the task is completed, so just print that seconds, then you can able to calculate. It is printing immediately. So these seconds are no use basically. You see this 100 is printing, 1 to 100 and 100 to 200. Two numbers are displaying right at a time, correct? So meaning two threads are executing parallelly. So that's what we are seeing the difference. See, 100 thread is completed, 200 thread is completed, correct? So these two are two different threads, correct? So let's say for instance, how you know which thread got printed this number, which thread is printed this number, correct? So it's if you want to display which does 99 is printed task 1 or task 2. So let me add some name along with that number so that we can confirm, right? Like two threads are running parallelly, correct? So I'm going to add here task 1 colon number, correct? So if the number is printing from which task, so I can see some label, correct? So now let me run it. And now maximize it. Did you see this? Task 1, task 2 parallelly, it's displaying numbers, correct? Done. So if you see here task 2 and task 1, both are running parallelly and it is displaying the output, correct? Did you see this?
Right.
So now, say for instance, if there is 100 threads are running, so how you know which thread is running? If you want to get the thread name, so how to get it? So now here I hard coded some name, right? Did you see this task 1? So I don't want to hard code like this. I want to give a specific name. So how to give a name to each task? Even if you're not giving name to this thread, how the naming will be assigned? So if you want to get that name, right? So there is a method called thread dot current thread dot get name. Meaning, so this is one task, right? One thread, right? So I want to get this thread name. How you will get this thread name? Thread dot current thread dot get name. Meaning it will give some name to this thread, and this is a different thread, right? Task 2 is a different thread, right? So it is having its own name. So if you want to see the default